Welcome to the Dreamcraft galaxy, where technology meets human potential.
Have you ever
wondered how a computer's brain, the CPU, works? This marvel of technology operates on a binary language, using a complex network of billions of transistors. These transistors, along with key components like logic gates, RAM, and a power source, make up the intricate ecosystem of a computer. Now, within this ecosystem, the CPU, using logic gates and an arithmetic logic unit or ALU, performs calculations. These calculations process binary bits, known as operands. Consider the Intel 4004, an early example of a CPU introduced in 1971. It was a trailblazer in its time, setting the stage for the advanced CPUs we see today. From decoding complex algorithms to running your favorite video games, the CPU is constantly at work. In essence, the CPU is the brain of the computer, performing billions of calculations per second to bring your digital world to life. But have you heard about the next big thing in computing? Quantum CPUs? Quantum computing, the new kid on the block, is set to revolutionize the way we think about processing information. Traditional computers use bits, the smallest unit of data, to carry out operations. These bits can be either a 0 or a 1, like a light switch that can be turned off or on. But here's where quantum computing takes a leap into the realm of the extraordinary. Instead of using these traditional bits, quantum computing uses quantum bits, or as they are more commonly known, qubits. Now, qubits are not just a fancy name for a new kind of bit, they fundamentally change the game. You see, unlike traditional bits, qubits can be both 0 and 1 at the same time, thanks to a quantum property known as superposition. This means that a qubit can hold more information than a traditional bit, but that's not all. Quantum computers also use quantum logic gates to perform operations. These gates are the quantum equivalent of the logic gates used in traditional computing, but they're supercharged. They can process multiple inputs at once, not just one or two. This means that quantum computers can handle complex tasks like searching vast databases or solving intricate optimization problems with an efficiency that classical computers can only dream of. It's exciting to think about what this means for the future of computing. With quantum CPUs, we could potentially solve problems that are currently out of reach for classical computers. We could simulate complex systems, crack cryptographic codes, optimize supply chains, and so much more. But it's important to remember that the real magic of quantum computing comes not just from the hardware, but from the software too. It's the algorithms that can take full advantage of these qubits that make quantum computing seem almost magical. The power of quantum computing lies not only in its hardware improvements, but also in the new algorithms that can leverage these qubits. So, what makes a quantum CPU different from a classical CPU? Well, it all boils down to their fundamental building blocks and how they handle information. Classical CPUs, the brains of our everyday computers, operate on binary language. This means they use bits, the smallest unit of data in a computer, which can be either a 0 or a 1. These bits are processed through billions of transistors, acting as logic gates, which perform operations based on the input they receive. For instance, the AND gate delivers a 1 or true only when both its inputs are 1. These logic gates, in conjunction with the arithmetic logic unit, or ALU, perform calculations that run our devices. It's like a giant, incredibly fast game of dominoes, with each piece triggering the next in a predetermined pattern. Now let's dive into the realm of quantum CPUs. Instead of using bits, quantum CPUs use quantum bits or qubits. These qubits can be both 0 and 1 at the same time due to a quantum phenomenon known as superposition. This means that a qubit can hold more information than a bit, allowing for greater complexity and speed in calculations. Quantum CPUs also use quantum logic gates to perform operations, which, unlike classical logic gates, can perform multiple operations simultaneously. This is due to another quantum phenomenon known as entanglement, where qubits become interconnected and the state of one can instantly affect the state of another, no matter the distance between them. The ability of qubits to hold and process more information, coupled with the simultaneous operations of quantum logic gates, means that quantum CPUs can handle complex tasks such as searching vast possibilities or solving optimization problems more efficiently than classical CPUs. It's like being able to play an entire orchestra's worth of dominoes at once, rather than one instrument at a time. While classical CPUs are powerful, quantum CPUs have the potential to take computing to a whole new level. So, what does this mean for the future of computing? With the advent of quantum CPUs, we're stepping into a new era, an era where computing power isn't just about faster processing speeds or larger storage capacities. It's about harnessing the strange and wonderful properties of quantum mechanics to solve problems that would take classical computers an eternity to crack. Imagine this: a quantum computer, with its qubits, can process vast amounts of data simultaneously. It's not about linear progression, it's about exponential growth. The more qubits a quantum CPU has, the more complex problems it can handle, and the quicker it can solve them. However, the magic of quantum computing isn't just in the hardware. It's also in the software, the algorithms that use these qubits. Quantum algorithms are like keys that unlock the full potential of quantum CPUs. They allow us to tap into the superposition and entanglement of qubits, enabling us to perform multiple operations at once, search vast databases almost instantaneously, and find optimal solutions to complex problems with unprecedented speed. As we continue to refine these quantum algorithms, we're discovering increasingly sophisticated applications for quantum computing across a plethora of fields. In the realm of cryptography, quantum computers could shatter current encryption methods, heralding a new era of secure communication. In the field of medicine, they could analyze genomic data at an unprecedented scale, opening doors to personalized medicine and targeted therapies. In the world of artificial intelligence, quantum CPUs could significantly boost machine learning, allowing AI to learn and adapt at an exponential rate. And in the field of climate science, they could simulate complex environmental systems, providing us with a better understanding of climate change and how to mitigate its effects. The potential is immense, and we're only scratching the surface. As we delve deeper into the quantum realm, the possibilities seem limitless. Quantum computing could be the key to unlocking new frontiers in technology, making what was once thought impossible, possible. Hey there, future AI explorers! Don't want to miss a single moment of our captivating journey through the AI galaxy? Make sure to hit that subscribe button and join us as we continue to unravel the mysteries of artificial intelligence. And don't forget to click the bell icon too. By doing so, you'll get notified every time we launch a new video, ensuring you're always in the loop when we dive into the next exciting chapter of our AI story. So what are you waiting for? Subscribe and hit the bell icon now, and let's keep exploring the wonders of AI together.